All right, so 3 minutes past 2 p.m. Good afternoon, everyone. Thank you for joining us today. I hope you can see my screen and you can hear me well. I can see that people are still joining, and so we can slowly start with the introduction. I'm Riccardo Pasculli. I'm taking care of the application support for several products at xCELLigence. And today I would like to give you an introduction for a very unique and special product which we recently got in our portfolio. It's the xCELLigence eSight, which combines the impedance and the imaging in a kinetic way inside the incubator. So the idea of this technology is in fact to keep your cells at physiological condition undisturbed for a short or long-term period, and for many different applications. The presentation will be basically focused on the application of interest. Okay, so Thomas has to leave, he said, unfortunately, but we will have the recording shared shortly on our website, so no problem. Okay, so as I said, that's the goal of the presentation, is mostly to speak about the application connected to this technology, and now I will give you a brief introduction on the technology itself. So the xCELLigence and Agilent, it has a solid record of publication. The idea of this impedance technology, it's in the market nearly 20 years. We have thousands and thousands of papers in really prestigious papers, journal for oncology to cancer biology, as well as more various field of research. And the idea of this technology, it makes really life easier on every cell culture lab, in my opinion, can benefit from this device. So you simply seed your cells either in the specialized plates or in the standard plates if you do just imaging. Then you place it inside the eSight, which is sitting inside the incubator at 37 degrees, 5% CO2. So you decide your setup condition, whether you want to monitor for a few hours or a few days. And then you just leave it running. And again, as the graphic said, relax and enjoy your coffee and wait for your data, or start to do analysis in real time since the zero time, because it's possible to start analyzing your data either after a few hours or after a few days. This is on the operator choice. And here you can see some example of the output. So this is the power again of the instrument, combined the output as impedance and live cell imaging with 3-color fluorescence plus bright field. But what about the impedance? So let's go through a little bit the principle of this really well-known concept for users which are not familiar with that. So as you know, this is one example of the xCELLigence MP, which can bring up to 6x96 per plate. So it's really multiplexing your analysis, but it's missing the imaging. And this is what the eSight is bringing. It's adding as a value. So the imaging, which was previously missing. Yeah. So you can see here these 2 front cradle plus 3 cradle on the back. The 2 front cradle, which I'm displaying here, are imaging only. So the user can decide whether they want to analyze here 96, 384 well plate, or many different formats, flasks, petri dishes, slides. So we have adapter for all common plastic. While at the back, you have 3 positions where you can use our ePlate dedicated for impedance detection, which are called view. So it means that at the bottom of these ePlates, we have, of course, our classical array of microelectrodes. So the idea again is that here we recreate the condition for our impedance monitoring. So it means that more cells are sitting on this electrode, higher is our impedance recorded. But at the same time, the viewing area allows the user to display a really nice, clear images in bright field or fluorescence, because we can use plate with glass or PET bottom. So the user can decide potentially even to get some nice confocal images out of this impedance plate. And the idea of the view area is in fact not affecting our resolution and not affecting our sensitivity, because out of our 90% coverage, maybe a 2% of electrode is removed to give access to this viewing area. Yeah, so you don't really influence your trend of the impedance results, but rather you get the added value because you can display the live cell imaging through this observation window. So imagine all done in one platform, which is sitting inside your incubator, that gives you really great power. And again, all of these are independent cradles, so it means that if your colleague has some experiment running here, it's equilibrated, you open the door of the incubator, but you don't need to open the cradle here. Yeah? So you can open your own, which is independent, so you don't really move their position. Maybe they're working with some suspension cells, you don't want to affect the stability of the experiment with the vibrations, so you can easily open just one cradle at a time and leave the other four in an independent way. So once again, just to summarize, there are 5 imaging possibilities, 5 imaging positions at the same time with different magnification, 4, 10, and 20x, 3 fluorescent channels, blue, green, and red, based on LED. And of course, the idea is that all the camera and the components are staying underneath our base where the plate are sitting. So your plate are completely in a static conditions. They are not shaken around by any moving stage, which is shaking your cells, and of course can also influence the quality of detection or can be not ideal for suspension cells. So here we have our undisturbed 5 positions, which are closed and not exposed to light. And underneath there is a camera with the objectives and imaging channels, different LED excitation, which is moving underneath. If you don't want to use plate, you can switch this to Petri dishes or so Petri dishes adapter, as well as the T25, 75 flask. So it depends what kind of format you're interested in. And once again, just to fix this concept, at the back of the instrument you have impedance plus imaging cradles. So what is the real summary of the value of this device? So if I would take a few of the points, it's really simple and easy. You are leaving your cells at physiological condition, you get a lot of rich data in a short time. You can imagine that you can get in the same time for the same experiment and the same results combined from impedance and imaging. Before that, it was necessary to get and try to put together, from 2 different platform results coming from the impedance readout and the results coming from the live cell imaging. Now we can do this in the same integrated platform. So really hands off, it means set up and walk away, and we keep the cells undisturbed at physiological condition inside the incubator. So again, only the imaging components are moving while your plate are totally static. And as you can see, the system comes with this anti-vibration feed. It's calibrated, it's leveled at the perfect way, so we get always the best quality of imaging, and this anti-vibration feed allows the cells to be undisturbed, to don't be like shaken by the moving of the optic underneath. So what is another point is the confidence that you can boost out of these combinations. So the robustness that you can get when you are combining impedance plus imaging. Of course, combining, for example, using the same plate which you use for impedance and imaging can maximize also your efficiency and can make you save definitely a lot of money, because you can imagine that originally the user were buying only this microelectrode dedicated e-plates for impedance only experiments. Now the user in the same time can even stain the cells which are located inside the E-plate, so the E-plates containing the electrode, and do at the same time, impedance readout, fluorescent count of the cells, as well as simple, for example, confluence analysis using the bright field image. Of course, the throughput is great. So it's an instrument which can serve, in my opinion, as a nice core facility option. So for a cell culture, which is doing many different applications, and shortly we will see together what kind of application we are covering, and the reproducibility is great. So why we decided to have this combination? Because if you take these two technology in a separate manner, as I already said, definitely the impedance alone and the imaging alone comes with a lot of benefit, comes with a lot of advantages. But if we see the combination in a synergic way, it's definitely, as I just said, cheaper to use this E-plate for both purpose. It's cheaper in the way that, of course, you can get quicker to the validation, to the reproducibility. So you need to repeat maybe 2 or 3 times less the experiment to get to some consistent results. So you need to use less reagents and less cells, not just about the plates, as well as the impedance compared to the imaging is really fast. So we speak about seconds to run the entire 96-well plate. So if you have some really fast kinetic readout, which your camera, your live cell imaging device cannot run, because of course there is a camera which is going well by well and scanning, while the impedance, as we are reading out column in a few seconds, we are able to cover, as I said, in less than like 30 seconds, the entire 96-well plate. So you can imagine what kind of power can be applied to fast kinetic experiments. And two things which, of course, personally I like, based on the experience with both instruments. So the real-time impedance biosensor, which is used in the eSight, it's label-free, it's non-invasive, 96-well plate in a few seconds, as I said. It's very objective, because compared to the live cell imaging alone, you can really just get the value which the instrument is generating based on the impedance, while of course the live cell imaging can add a little bit of subjectivity into your flow, right? Because when the user is going to do image processing, adjusting the fluorescent signal, sometimes requires some experience. And of course, there can be input of subjectivity into the analysis. Yeah. So the live cell imaging, now it's displayed 10 and 20x objective, but we are going to release soon the 4x for the whole well imaging. There is bright field, 3 fluorescent channels, and of course multiple type of output, image, video, and different dyes which we provide. Of course, everything is non-cytotoxic, and here we work in a way that we use LED for excitation. So this is introduction from the technology. Now we can go through the applications, and if we consider what is the best of both worlds, so the so-called multiplexed application, I'm displaying just some of those. Of course, there are many others that the user can think about, but what is the ideal, for example, like key application which we can use when integrating in a synergic way the impedance and the imaging. So you can think about some simple cell health assay like apoptosis, proliferation, and going more into specific application like the scratch assay, which comes with a kit. We will see it later. Immune cell killing using CAR T cells, and there are of course a lot of time invested into virology related application. So if I want to show you one example of the output of the proliferation, here you can see the nice example of the image quality. So we get a really undisturbed cells over time. As you can see, we focus always on the same field of view. And we can combine here, in this case, the fluorescent count coming from our reagents So there is a nuclear staining which we are using, the lentivirus in this case. And at the same time, we can get the results from the impedance. Yeah. So we can combine our basically the so-called cell index, which is our readout of the impedance. It's really directly correlated to the fluorescent cell count. So this is quite nice example. Yeah. And apoptosis can be another type of cell health assay. And here you can see, in fact, the example of cells which are stained and with annexine, so with the nuclear staining, which is in blue, plus the annexine red, plus the caspase. So we can get 3 types of fluorescent readout, plus, of course, the bright field. And at the same time, so we can monitor 2 different mechanisms of apoptosis coming from the annexine complex or the caspase activation. And all of these can be correlated again to our cell index value, which is our objective readout of the impedance. Yeah. So it's really nice, straightforward, and really high throughput. So 3 colors at the same time, plus bright field, plus cell index, makes a total of 5 parameters in the same experiment, which is really impressive. If we want to consider a bit more sophisticated type of application, you can see here the immune cell killing using mediated by CAR-T. So here in this case, we have our activated CAR-T and inactivated CAR-T, and we are basically monitoring the killing of our cancer cells. So we can compare basically the efficiency of killing. Of course, this video it's a bit speeded up to since it's quite long type of experiment here, but you can compare here clearly your negative control where the cells are not recognizing the marker of the cancer cells with the activated CAR-T. So it's really a nice example. And also in this case, we can of course see and correlate really nicely the impedance profile with our fluorescent count and fluorescent intensity, of course, because the user, of course, can decide in the live cell imaging which are the parameter of interest. Another cell health assay, also here, really beautiful bright field image, very stable, nice autofocus. That's personally, I like it a lot. And it's stained with the lentivirus red, plus the so-called ETOX green. So the ETOX green is the marker of cell death, and of course, in the positive control where you have your toxic treatment, you can see that there is definitely a higher amount of green signal which express the cell death. And on this right side here, you can see once again the so-called normalized cell index, because using the impedance, we can of course do normalization exactly at a time point where the treatment was added. And we can nicely see that our impedance profile nicely corresponds to our imaging. Scratch assay, so not only like different type of immune cell killing and cell health assay, but we have also kit, which comes with the Woundmaker tool. So the Woundmaker tool basically is capable of doing 96 uniform scratch with 1 click. And the idea is basically that this type of tool can be used with any 96 well plate, as well as with our specialized impedance scratch plate. Yeah, so we have dedicated plate for impedance, which are in fact the scratch plate. In this case, the scratch plate has electrodes only in the center, in the scratch area. And of course, here you can see that the cell index in this case express the amount of cells which are migrating on the electrode. Yeah, because at the 0 time, the electrodes are empty. After the scratch is done, the plate is washed. While after time, we basically again correlate our scratch wound. So as you can see, the scratch wound basically decrease the signal from 12 to 0 nearly, and then we monitor the migration speed. And this can be done again in the same plate. We can get the imaging, so we can do our analysis of the confluence, our analysis of the, the health of the cells, using, for example, some viability staining plus the migration speed. So once again, a lot of parameter in the same experiment in the same plate. In connection to virology and vaccine producer, definitely there is also a lot of different vaccine producer. They used previously the xCELLigence, and definitely they were really happy also to test the eSight. So if we take this example here, where you have the virus alone with the hex cells and the virus plus the neutralizing protein. So the green marker express the infective rate, so the infection rate of the cells. And as you can see, where you have the neutralizing protein, there is really few compared to the virus alone. And this is our imaging results. And what about if we are going to compare exactly in the same well, in the same plate, the condition coming from our impedance, our cell index? So also here, as we can see, where we have our negative control, we can see a growth, undisturbed growth of the cells, and then the spontaneous cell death. Cells plus neutralizing protein shows a slightly faster cell death, because of course a little infection is happening, while the cells plus virus alone without neutralizing protein shows faster and clear infection, and of course detachment of the cells, so the cell death after 40 hours compared to the negative control after 70 hours. So once again, really nicely comparable, and a robust validation of the experiment in a really faster way. So it's not just about the device, it's about also reagents which are provided together with this technology, because we want to help you also in preparing your sample. You can see nice example here of reagents, and Agilent is now working on more release. But as you can see here, we can cover nicely the cell health field in a different way. So all these videos which I was showing you are nicely covered by these different dyes. So if you want to stain the live cells, we can use the live red, green, or if for longer term experiment, we can use the lentivirus, also in blue. So once again, 3 colors at the same time are available here. And for marking the apoptosis, there are different mechanisms, either activation of caspase or annexin complex. So the user also here has really wide choice of color and pathways to monitor the apoptosis, as well as the cell death. So the cell death can be, of course, identified by the activation of the ETOX red and ETOX green. And what about application where we could benefit maybe mostly from the imaging? Yeah, because of course the platform has these 2 different special locations where there are, as you remember, at the back of the machine, 3 cradle, impedance plus imaging, and these are the applications we just discussed. But what about more sophisticated, more complex application where the impedance doesn't give us really information, but the imaging alone can help us? And you can see here some example of imaging only applications, so phagocytosis, immune cell clustering, 3D spheroids, the invasions, for example, sometimes can be one application where not always it's reliable to work with impedance only. And you can see here some nice example of phagocytosis. So the phagocytosis in this case comes with some particles. So these are macrophages expressing GFP plus bioparticles of E. coli. So these are inactivated E. coli, and you can see the bioparticles are all around. So as soon as the bioparticles are internalized, they're exposed to the low pH, the endosomes, they activate the fluorescence signal. Yeah, so you can really nicely see and compare the results depending by the concentration of the bioparticle, depending by the macrophages, they are activated or not. So this is another really nice application where, of course, the impedance cannot give us much information, so we can work with our standard plastic in the front, in the 2 front position with imaging only. 3D spheroids, It's a very sophisticated application where, of course, required to have a really good image quality and a reliable autofocus. And you can see here that even though we have just an inverted microscope, we can get a really nice 3D image and stable autofocus over a week. So here we have used our basically red viability dye to stain the nuclei of the cells, plus the ETOX green as a marker of the toxicity. And you can see here, depending by the different condition, of course, we can at first identify the changes in area and morphology just using the bright field mask, using the bright field analysis mask, as well as if we want to identify also the qualitative information about how healthy are these cells, we need to use the other two colors. Yeah, we need to use the other two channels, which is the red and green. And of course, the user can correlate the area of this signal, the intensity of the signal, to check which is the treatment which is like promoting or inhibiting the proliferation and formation of these spheroids. And here you can see another example of how the mask is applied over time. Yeah, how our algorithm works really nicely over more than a week. And that's the parameter which express, in fact, the cell depth over time. So for the immunotherapy, I just show you before the reagents which are connected to cell health mostly. But for the immunotherapy, of course, for the user which they are starting, we help also to prepare the sample. So for example, depending if you're working with liquid or solid tumor, you might need some factor for the adhesion in the bottom of your plate. So we provide our so-called kit either with just with the coating or even with the antibodies. Yeah, so the idea is that the user can create nice monolayer of cancer cells using this coating and tethering kit at the bottom of the plate. And then after the monolayer of cancer cells is created, there is the step number 2, which is the addition of the effector cells and monitoring of the cancer killing. And there are different markers directed to, of course, different type of cells. You can see here the target cells that we have tested. So yeah, for the user, again, which they don't have really any protocol, they are starting this field, we try to support and to help you in the first steps. The software is really nice. In the near future, I'm planning to do some other webinar dedicated to the let's say demo, remote demonstration of the device. So it's super easy to set up the experiment. What is nice is that each of the position has independent interval. So each user, each of the 5 users with the 5 position can have independent interval time, can have independent duration, can choose independently, of course, the objective, you know, if they want to scan with blue, green, or red. So it's really making this device like 5 microscopes at once, plus, of course, the impedance readout, which is a great added value. And there are dedicated modules depending by the application of interest. Agilent is working on more, so we are planning to expand our application capabilities also, depending, of course, on the great feedback from our existing users. So just to summarize a little bit of technical features, as I said, the impedance can make a super fast readout, so 96 per plate in a few seconds. Now it's displayed 10 and 20x objective, but within a few weeks we will have also the 4x. Really high quality bright field, 3-color fluorescence based on LED. So once again, no disturbance to cells, really low phototoxicity. And here you can see a little bit of the technical specifications. So most of the dyes are used for live cell imaging are compatible. Plus, of course, you can think about RFP, GFP, and BFP. So if you're working with a fluorescent protein, it's really convenient to multiplex, and different type of output image. So the user can either export video or a set of pictures. To summarize, this instrument is really great, again, for the combination of real-time imaging plus impedance. you can, as I mentioned, really set up the device for a core facility in a way that 5 positions are having totally independent settings, independent applications, so you can get nice multiplex out of one device only. Objective data with high reproducibility, because as I said, the data coming from the impedance can help you to don't input too much subjectivity in your image processing. So you can get a lot of confidence, and out of all the software, it's really easy and comes with really powerful dedicated algorithm. So you will not get lost into the analysis because the software has this dedicated module for different application. So if you want to do scratch assay, you will have your 3 to 4 parameter of interest, and you will not have to pick from 100 of different parameters, which sometimes I see in some imaging software, where the user has to decide out of a list of 100 parameters, which is the proper one. So here there are dedicated algorithms, and if you want to do scratch assay, you know that, for example, the scratch wound confluence is the right parameter, is the most meaningful. So saving time a lot. And there is a nice testimonial from Dr. Gouveia from Institut Curie in Paris, and she is working in the field of the oncology, immune oncology. So she's working a lot with CAR-T, and definitely she tried different type of imaging platform inside incubator, but at some point she was feeling always a bit scared about the subjectivity that the image processing bring into your workflow. So having these two combination at the same time was making feel her really comfortable in getting to some conclusions faster and easier than just having the imaging alone. And there are more of these resources. So for our client from Hungary, they can refer to xCELLigence. For Polish, of course, we have our Polish branch at omixis.pl. So you can find really a lot of nice information at our product page. And this is my email here. So of course, if you like to ask some question, we can have a nice discussion right now, or I will be happy to answer to your email later on. So that's it from my side. Thank you for your attention. Anyone has any questions or comments?
So maybe I can start, Anna Stanisławska. Thank you for your presentation, and it was interesting to hear. I have learned a lot. So actually, I don't have many questions at the moment, but maybe they will appear later if we start thinking about this machine more in detail. But that was interesting. So anyway, thank you for giving us this presentation.
Thank you for joining. So if I may ask, maybe what applications are you actually into?
The scratch as a model of injury of the cells, but I know that many people in the department are considering biofilm creation, so maybe that might be also something of interest in general in the department, but really the people have to speak for themselves. But maybe the scratch might be something that we would be interested in, because then we would see the difference of the lifetime, the way the scratch is just well, I don't know, disappearing, I would say. The cells are moving, so that might be interesting.
So both applications are actually quite okay for this technology, because we just finished recently a test, especially about biofilming done with xCELLigence, so impedance only, and we see that it's really sensitive because there are microelectrodes which can be good enough for not only for cells adhesion but also for bacteria alone. So yeah, I believe that we can cover both of your, let's say, field of research.
Right, thank you.
Okay, thank you for your input. And if you have any more questions, just like feel free to drop me an email or to ask our local managers. So if there are no more questions, then I'm going to end the session here, and I will be sharing the recording with you.
Right, thank you.
Thank you for your time.
Bye-bye.
Have a nice weekend.
Your local
Thank you.
representative in Poland is also available all the time.
Hi, Pietro. Yes, thank you. Okay, bye.